even though we like to trust people, the reality is in the modern food production facility, you can't trust anyone. And all they had to do was go, and I know I'm not testing earlier on, but that's a simple test, isn't it? If it's warm, dry, and it's obviously not been dried sufficiently, we assume it's been processed sufficiently, then that's an issue, and ensuring that everything's sanitary. So even if you know the person, don't always check the loads before you go in, because it can be devastating.
Hello and welcome to the Feed Science Podcast. I'm Adam Fairnolds here at North Carolina State University, and today my guest is joining me from the University of Guelph. This is Keith Warriner, and he is the Professor of Food Microbiology there at the university. Keith, how are you doing today?
Good afternoon.
Great to have you. So we've had all kinds of different folks so far join us on the podcast, and we hopefully got a lot more in us, and we've had folks that have done things on the feed milling side very specifically, or on quality, different researchers involved, and we're always trying to get some different new perspectives, and you've got some different perspectives to bring from that microbiological side of things that might be happening with the animal food and with feed mill. So I think that's where a lot of our conversation will go today. But to start off, if you wouldn't mind, if you would give the audience a bit of your background and how you came to be where you're at, and what you are focusing on now there at your program at the university.
Right, it's a very interesting story, my background, when you look back on it. When I left school, I actually became a chef. And, with chef's life, it's not so good. Waking up at 5 o'clock to give people breakfast and then going to bed at 11 o'clock at night. And so I kept that up for about 3 or 4 years. And then I literally saw an advert in a paper talking about a food science degree. And so I basically thought, yes, this seems a better alternative than being a chef. So I did a diploma in food science, and I went to the University of Nottingham to do a degree in food science. Then I kind of switched gears again, and I went to the University of Aberystwyth in Wales to do actually a degree in microbial physiology, which was looking at the physiology of lactic acid bacteria. And then I even did another jump to go to the University of Manchester, where I worked on biosensors for glucose sensors, creatine sensors, things like that. And then I returned to the University of Nottingham to become a food microbiologist. And then back in 2002, which seemed an age away, and again, it was just by passing an advert in a paper. But I saw the University of Guelph wanted a food microbiologist, so I applied for it, and obviously I got it because I'm here. What we've been doing over the last 20 years in developing our sort of food safety program, which is basically food safety, but also goes into other areas, is focusing on intervention strategies, because there are different strands of research. You get the fundamental research that says gene A looks at gene Y to have an effect on what X. You get to diagnostics saying, we can measure things. But in our research, it's always been mostly applied. So we're there to solve problems. And the sort of problems we've solved is to do with things like decontamination of fresh produce. And we've looked at how produce gets contaminated, how pathogens interact, and we have interventions. We've obviously worked on biosensors going back to my University of Manchester days on detecting not only pathogens but mycotoxins. We've also done fundamental research, which has taken us into the field, looking at the ways animals acquire pathogens, so the pathogens that affect us as consumers, and then try to bring interventions to that.
Okay, so you mentioned something there at the very end I think is an interesting maybe place to start. When you think about things from a food safety perspective, pathogens, like you said, it could be mycotoxins, it could be enteric pathogens, whatever. What do you see are any of the differences or challenges, let's say, looking at those that might actually impact the animal versus those that might go through the animal and all the way into people, as far as when we look at the severity and what kind of mitigations we should be looking at, where our strategy should be?
Very interesting question, and the reality is that we have silos, we call them in science. In that, food microbiologists stay away from pathologists, which obviously are the ones that are more focused on that. But I think research industry are starting to consider this what we call a One Health approach. Because in the food industry, I remember when I first started here, going down to certain commodity groups, say. And you would suggest to them, saying, really, you need to solve issues at the farm level. And their attitudes were, well, no, processing takes care of everything. But as we know from lessons learned, it's not always the case. So is interventions that can be applied at the farm level, which both handle human pathogens and the animal pathogens. And one very good example is our recent research in developing decontamination methods for hatchery eggs. So what the project was to do with is actually inactivating things like Salmonella and Campylobacter. So they prevent, obviously, getting into the food chain. And the good thing about our research is we collaborate with a lot of different partners. And obviously at the hatchery level, Salmonella is a thing, but the big things are like Apex, the avian pathogenic E. coli and things like that. So we do get crossover with that, but it's interesting. Research is kind of shifting towards it. But even now, if you put in a application for protecting animals rather than basically preventing Salmonella, it doesn't get a very good view. And it's quite interesting. I was involved in a project where I was trying to express this, how we could not only control human pathogens, but animals. And they said, no, animal pathogens are separate. So there's a way to go, but I think people are cottoning on that say, yes, if you prevent pathogens at the farm level, then you get other added benefits. And, it's interesting looking through, again, past these 20 years, how one of the most important things in farming, especially animal farming, is literally sanitation. And I was quite amazed, at the standards some have, even in the food processing industry. But I think, again, things are turning.
Sure. No, I think so. And it's an interesting conversation that I know we have, especially, I think it's kind of happening worldwide, but it has it's almost kind of a hierarchy, I think, things that happen in Europe and then things kind of in Canada and then down into the US as far as looking at some of those different, especially on things like pathogens, and looking at that and saying, okay, do we just focus on, well, is this a food safety issue or not because it impacts the animal? Or is it a food safety issue or not if it doesn't impact the animal but could impact people? And, so for example, on pet food, okay, if the pet food, because it's going into the home, no salmonella, period. Can't be there because people are going to be handling it. Small children might get access to it, that sort of thing. As we're on livestock feeds, we say, look, it's not being handled by people. If it's not going to make the animal sick and we don't see it pass through the animal to the humans, if it's not a pathogen that's got a serotype that is impacting the animal, maybe then it's not such of a big deal. But we see different places around the world look at it differently, and we all kind of seem to be moving in that same direction. As far as mitigation strategies for things like food safety issues specifically related to these biological problems, what kind of things have your research shown on but I know it's not all focused on the animal food side, but, just kind of expanding into that animal food side, what kind of things seem to work and what kind of things do people maybe think that work that, that's really not worthwhile. That's not doing anything.
That's a very good question as well. The ongoing philosophy, still now, even though people don't, it doesn't really work very well, is the art of testing. So every time there's an outbreak, every time there's an incident, people fall back on testing. And the reality is, testing is like a safety net. Unless you've got a really tight net, a lot of samples, and the target's fairly high, then testing is going to be really challenging. And I've seen it, especially with the fresh produce people, that when there's an outbreak of E. coli to do with romaine lettuce, they do 5 samples and say, if they're clear, we're good to go, which isn't right. And there is a kind of drifting now towards real interventions, and it's taken a long time. And the one we kind of developed is based on what we call the hydroxy radical process. So this is where you have basically hydrogen peroxide mist, ozone, and UV converts that to what we call hydroxy radicals. So hydroxy radicals are found in nature, in the clouds, where they're thought to control pollution because we've got ozone there, we've got sunlight to produce these radicals. And we focused a lot of time on fresh produce like fruit and vegetables. But we actually did do a project with raw pet food because, as you rightly said, it's becoming much more popular now for one reason or another. And the reality is that other ways of saying, well, let's wash it in sanitizer like chlorine or peracetic acid, they don't work at all, because at the end of the day, you've got the quality of a product to think about. And I think with our research, that's one of the big things, is that we don't just go in there and say, well, we're going to decontaminate it. You might not have anything left afterwards, but it's not going to have salmonella. We actually look at the quality of it. And in that project we did with the pet food, we basically demonstrate how we could inactivate salmonella on it was frozen pet food as well, because the process is so rapid that it can be done. So to sum up then, basically you need effective interventions, but you need to always balance quality versus safety, and also bring tangible benefits. Tangible benefits being maybe extended shelf life and things like that. But as I say, the most frustrating thing is when people say, well, we'll test our way to safety. It never works. And the trouble is they generate data which they don't understand too much, and that makes it even worse. So that's the way it goes.
Yeah, I know I've had a number of conversations, as have other folks that I work with regularly on the quality food safety side of things, and especially in those facilities, like you said, like a raw pet food, where having a mitigation strategy is really difficult because you take cooking out of the equation. And that idea of, well, we could test every lot. Oh, well, or we could test even more than that, and getting everyone to understand, no, that's good. That's a good practice to do as far as to verify that something else is working. But in and of itself, the testing is not a control. It is a verification step at best in most cases. And that's that you're right. That's something that's hard to get folks into. You also mentioned the safety standpoint. Unfortunately, that's another part outside of the potential cooking process, whether it be, extrusion in pet food or pelleting. I'm assuming that you then somehow keep the system closed and don't reintroduce, something using ambient air and that sort of stuff, which we most often do when we're doing thermal processing in animal food. A lot of those mitigation strategies we have for things like pathogens aren't exactly things we like to handle very much. A lot of them are somewhat unpleasant. Have you guys specifically looked at any of that in your work, as far as the things that work well that also maybe are a little less undesirable to work with? Like, formaldehyde works really, really well. It's a really good product from the standpoint of working, and has worked for a long time, but it's got obviously some concerns with people working with it. So are there things that you found that work pretty well that actually also aren't so horrible to deal with?
The formaldehyde question has been really risen in the hatchery business, because I visited a hatchery once, and for those who don't know about fumigation by formaldehyde, essentially what you do, you get a closed room and you've got two chemicals and you kind of activate them, and you better get out that room fairly quick because formaldehyde knocks you back. And but that week I was visiting, saying, well, we nearly had a close call because somebody tripped over and nearly didn't get out the room. I thought, wow, that's the job to go to, isn't it? But there's other things as well, such as the byproducts. And in Europe, they're definitely moving away from formaldehyde. So even though it's traditional in the hatchery business, certainly there is dangers to it, not only for worker safety, but going to the point of the actual byproducts form, because in Europe they're obsessed with byproducts. Oddly enough, they're not so interested in pathogens, even though they've got a pathogen problem, but they're very interested in things like that. And what you tend to find is, as you probably experienced yourself, is things tend to migrate. So what happens in Europe tends to happen in North America a few years later. And to that end, thinking about hatchery eggs and things like that, there has been sort of alternatives like ozone introduced. Ozone, again, isn't the most pleasant gas, certainly has a negative effect on hatcheries. Chlorine dioxide has been a favour. Again, if you're causing chlorine dioxide, you don't want to, you want to hold your breath a bit. And again, it's devastating. So in our process, we don't have this sort of batch system. It's a continuous one with a hydrogen peroxide, UV, and ozone, and it takes about 10 seconds to decontaminate eggs, so you can really put a few in. And it's really, hopefully, after a few commercial trials we've done, it's looking very promising. But what you come across is this sort of barrier to adoption of technology. And it's quite interesting. As researchers, we tend to go in the lab, we spend day and night sometimes working on projects, getting the funding in to get them done. And you deliver a product saying, look, this is an alternative. And it's amazing how the industry kind of has a barrier to it, saying, well, do we really need it? Our traditional approaches. And that was quite eye-opening to me, is that how far you have to go. Even now, when we've got a validated system, published research and whatnot, you get industry saying, well, not really sure, even though it's a viable alternative. But certainly, again, it's this case of balancing out things. You can't just come with ozone, chlorine dioxide, and say, yes, it kills everything. You've got to have something afterwards. But we really have to be cautious now, especially of the old methods. I remember using glutaraldehyde in the hospitals once. Formaldehyde, all these. We've got better technologies now. We kind of have to use them.
Once again, my guest today is Dr. Keith Warriner, Professor of Food Microbiology at the University of Guelph. Continuing on that conversation, I agree with you, when there's those new technologies, and certainly in the feed industry, even if we separate the feed industry out from, let's say, the pet food industry, take the animal food and split them in two, that adoption of technology is always going to be a little further down the line. And as much as anything, it's going to be related to, as you said, we have these old ways. The old ways seem to work fine. It also has something to do economically. The margins are different. The ability to invest in the new technology is different on that livestock side. And so it needs to be proven somewhere else. And then the technology costs need to be realized and come down a little bit before we can use them. But I also think some of the other points were interesting from the standpoint of going back to that formaldehyde discussion. Is it something everybody likes to work with? No, maybe not. Is it the safest thing to work around? No, maybe not. But at the same time, it works. It works very well. There are certain pathogens, and knock on every piece of wood we can find. We have something like African swine fever that we know that's a product that could do something with, and yet we hear, well, we'd like to phase it out because it's not safe. And we say, well, but hold on, are there other alternatives that are feasible? And even if those ones that are feasible are also not necessarily the greatest things to work with either, then what's the rush until we find the right thing, I think.
Quite interesting is that, people like to cling on to the old methods and that. And the reality is that it has to be signs of change, or you have to kind of change the way of thinking and look at the investment. And what was interesting is the technology we developed in the lab actually did get commercialized by CleanWorks Corp. And when we got this sort of boost, if you want, commercial boost, it was interesting that it always was from a crisis. So to go back a few years, we developed a system. We've been working on this system for about 10 years. And in 2015, we were approached by a candy apple maker, of all things. So back in those times, in 2015, there was a listeria outbreak linked to apples, candy apples especially. But it wasn't the actual person who came to us that had the problem. It was a problem in California, and it really had a devastating effect. All the retailers said, look, we're not going to stock candy apples ever again. If we do, you need to go refrigerated, which made no sense at all because listeria grows under cold. But the thing is that when the company came to us, and said, look, we're interested in UV. And I said, no, I've got another system which really can boost it. Yeah, the hydrogen peroxide and ozone and UV. Anyway, to the point is that we've proved it was successful, and he introduced it. And basically what he did then, he got a big mark on all the other candy apple producers. So when they were allowed in the store, people would come to him for the simple reason he's got a decontamination step. He's not coming up with testing. He's not saying, I'm going to wash them in chlorine. And that was a boost to his industry. I think his market size just grew by 10%. And the other sort of boost was during the pandemic. I won't say which one. And again, because people were looking for PPE decontamination. And they looked at our system and said, yeah, that's just what we need. And they introduced that. And again, it gave you this sort of coverage that you would. So when people talk about investing in technology, I know, especially in the food safety circles, they always say, well, how much is it going to cost me? Because I know food safety doesn't sell. And this is the importance of having tangible benefits. And in our sort of system, our tangible benefits are, well, for the masks, you can just use it where you are rather than have someone else mask to wear later on. And in terms of the candy apples, it extended to shelf life. So that's the kind of things you focus on. But you're right what you say. A lot of people always think about saying, well, these methods have served us well so far. Yeah, they have, until somebody says, yeah, formaldehyde is totally banned, like the diglutaraldehyde and the old methyl bromide used to be in its day. So there is these kind of things. And I think people adopting new technologies do get a lead, especially now because of the power of retailers and whatnot.
Yeah, I agree wholeheartedly that being that first adopter, I think is proven in all kinds of different industries and different spaces throughout retail and throughout industry, wherever. Being that first adopter to something that works ends up usually being pretty good, because to some extent you can get an economic benefit or realize a marketing benefit or that sort of thing.
I think what you have to do is really be cautious. In the food, and I'm probably sure in the animal feed business as well, in any business, the market is dominated by snake oil salesmen. And I remember when I first came here, there was a big fuss about ozone, saying, ozone can cure and do everything. And people have been sold systems for $250,000 and they never delivered. And I think this, again, comes to the point of being a first adopter means you're like the first animal into the field, in that if there's anything there that's going to get you, it's going to be the first one. And so you need to be very wary about the promises made, and not just having words, but actually looking at data. And it pays to even have consultants look at data, because I've seen in the UV business, in the ozone business, in sanitating business, a lot of people get stung very quickly.
Sure. Yeah. No, I think that's also an excellent point. There's always some new additive or new, like you said, chemical or something that's going to solve everything. We certainly see it plenty in our industry, where something comes in and this is going to make a better pellet. It's going to also help with some sort of pathogen resistance. It's got a nutritional thing. You look at some of those and go, well, if that's good, I assume everybody's using it, right? Well, no, we don't have that many people using it yet. I wonder why that may be. Switching gears a little bit, I believe your lab also has done some work that I think some folks in our audience might be interested in hearing something about, on the impact of the use of antibiotics and where that's tied into resistance and some other things like that. And that's, while a lot of our folks may not necessarily be on that kind of epidemiological side of things, we have seen medications come and go in the feed mill, and we've seen moving towards no antibiotics ever, and now we've seen some companies actually coming back and saying, well, that might have been too far. What are some of the things that you guys have learned as far as where that might be headed in the future?
It's an interesting story about obviously antimicrobials in feed. Going back to when they were first discovered, I think they were abused right from the get-go, because even in the 1950s, people were starting to see antibiotic resistances. And the reality is that over in Europe, they actually banned antibiotics way back in 2000. I think 2006 was the when we're all banned. And the problem here in North America is that we use antibiotics to compensate for poor sanitation. Yeah, because sanitation in animal production here, and you compare it to Europe, is very different. And it might seem logical saying, well, yes, if you got unsanitary bars, high in density animals, you're going to get problems, and you do. And they say, oh, let's use an antibiotic in order to control the pathogens and protect them, which worked for a while, obviously. But, I always say nature has a way of beating nature. It's like this arms race. And when, obviously, as a food microbiologist, our sort of first contact is to do with this sort of initiative, which was by a fast food chain, to say we're going to go antibiotic free. And the reality is, anybody in the business knows there is no real antibiotic residues. You can't just stick antibiotic residues in meat and expect it to be accepted. So, and I think that's where this sort of train of banning antibiotics really picked up speed. And I always think about the antibiotics as a bit like prohibition back in the 20s and 30s. You either have them or you totally have absence of them. And obviously that was a disaster, because it's all right taking antibiotics out, but if you don't replace them with something, then you're going to have issues. And, I saw all this research going on about essential oils, zinc oxide, and all these other things, which we know, and even bacteriophages, we knew even then these aren't solutions. So what's interesting about the antibiotic banning argument, I always put this in class as well, is saying, okay, is there a risk of what is the risk to do with antibiotics in animal production? Obviously building resistance, and which when we acquire them, that's going to be resistant to antibiotics used on us, and we're going to get secondary infections and whatnot. But the other part about it is animal welfare, because, when you say to people, well, your mortality rate is going to increase if you've got no protection, that's going to be an issue. So going back to your point, saying, some are reoccurring, basically what we like to call it, isn't it, is antibiotic stewardship, as in, I remember being at a conference once, someone made a very good analogy, saying, we're going to be the Budweiser of antibiotics, which basically means you have it occasionally. You're not banning, you're not certainly champagne. But he had a very good point, is that you use them, you manage the antibiotics, so you don't deprive animals of antibiotics, and you use them when you need to, but don't let it be a compensation for poor sanitation. Because the reality is, and animals get the brunt of it, saying, oh, it's animal feed and that. But, I think we all know aquaculture is a lot to do with antibiotic resistance. And the people, they go to the doctor's automatically used to, anyway, in the good old days, give you a prescription for antibiotics. You feel better in a few days, and then you just say, well, I don't need any more. It's time to get the drink going and things like that. And obviously they build up resistance as well. So in terms of antibiotic resistance, we see it, certainly, as I say, we kind of focus more on the food side, but we have got into farms and looked at ways to reduce it, irrigation water, but focusing on the sanitation. But certainly antibiotics, in the very nature, they are going to obviously become more redundant. And I remember some Clostridium perfringens with chickens, for example. The reason to stop using them, not because they wanted to sell to fast food chains, they just weren't useful anymore. And what's interesting also is that, people say, we need new antibiotics. And there was an interesting antibiotic, I don't know if you remember trioxidin. Well, basically what this was is a brand new class of antibiotic after 30 years. And they did clinical trials and demonstrated efficacy. And you would have thought the drug companies would have really leapt onto it. But the reality is it never even got to drug trials. And when you hear stories about, we've got a new class of antibiotic, AI has discovered it, made a new antibiotic, the pharmaceutical companies don't want to invest in it because in their mind, the antibiotic resistant crisis has to come so much that then it becomes profitable. And I found it a bit alarming that, but I can believe it's true. So certainly we have to manage antibiotics. Europe's done it quite well. And can we get those kind of conditions over here in North America? And that's a big question because it's totally different farming practices and whatnot.
Sure, yeah, and it's always been interesting from the feed side of it. We want the animals to be healthy, and we want them to have good welfare, all these other kind of things. At the same time, nobody in the feed mill specifically. So I'm not talking about managing live production or anything, but just the feed mill specifically. We don't cry very much when someone wants to remove the antibiotics, because we say, oh, okay, well, that's one less thing to inventory and do the record keeping on and regulatory. When they show up and we say, oh, we don't have any here, then that's a lot easier. But it does seem like maybe, like you said, like that pendulum swung from they were overused and to the point where maybe people weren't doing the husbandry things that they should have been doing because the not even necessarily intentionally, but not seeing problems that were coming up from poor husbandry because the drugs were basically overshadowing that or controlling it, sort of a thing. And then we switched to these, no antibiotics ever. And maybe that has helped a little bit with the husbandry side of things and making people have to do a better job. But then maybe they've realized, yeah, but like you said, the data doesn't necessarily suggest that has made some sort of huge dent in, overall, antibiotic resistant infections in people and things like that. So maybe they're still a tool that we should have. And I also think the consumer, you made a really good point. I think most of the consumers are thinking along the lines of, well, I don't want that because I don't want it in my food. And we all wave our hands and say, it's not in your food. Like that's been a rule from, the very beginning. It's not that. It's more of a concern about potential resistance, but also, and I really like your point there, have you thought about the fact, though, that when we use these, the animals maybe have better welfare in certain cases. And when they do get sick, which is going to happen no matter how good the husbandry is, we want to have this tool, and you don't want that tool taken away. The animals would suffer. There may also be things related to sustainability. And if we use these, perhaps we can use some more sustainable practices and other things that we do if we're there. So I think the topic is actually a lot more complex than folks like think. And we've seen, of course, too, the data that has suggested in the past that sometimes when everything is banned from a prophylactic standpoint and a good management isn't put in place, they end up using more for a treatment than they would have used from a prophylactic standpoint in the first place, because there wasn't a plan before the ban went in place. They just stopped it and then went, uh-oh, well, now what do we do? Because they didn't plan to do something else. So
it was quite interesting after the ban was banned. This voluntary ban was put in place. What farmers resorted to is actually getting antibiotics on the market. They would, and especially in developing countries, this is the biggest problem in that they get antibiotics even if they're outdated and things like this, and they use them without supervision, which, as you know, it makes the problem 20 times worse, for sure.
Well, it's been a really very interesting conversation. I wanted to ask you before we kind of get here on the close. I would imagine that potentially with the work that you've done on the food microbiology side, that, and as it happens with universities, for those in our audience that don't know, when something comes up, a problem somewhere, whether it be something that's just a company doing some sort of quality control, or it is actually something where there's been a complaint made, they like to search out folks at the university that, in theory, don't have commercial ties to people that can act as an unbiased reviewer of things. I was wondering if you might have any interesting stories from over the years of things that showed up that might be related to animal feed, that had something to do with microbiological concerns that we wouldn't have maybe thought of before.
Oh yeah, I've got a few stories actually. I think we could do a separate podcast on one. But basically, as university people, we are that kind of middle ground in that third party. And I know some people say, "Are you in bed with industry and government?" It's not quite the case. If we were, we wouldn't be sitting here. We'd be in industry. And I can't tell you, obviously, the specific details, but it was an interesting case which would be of interest to animal feed producers and also farmers. So what this case was surrounding is a feed supplier used to make a custom feed for a goat farm, and no problem, they're all pally together, and what they would do is they'll deliver the feed, the farmer themselves will put it in a silo, then feed the goats and get baby goats, kids I think they call them, isn't it, and get milk. Well, what happened on this one occasion is that they got delivered some feed and they stored it and they fed it to the goats, and within a week about a quarter of the herd has died. There was abortions of kids, and it was pretty devastating to this goat farm, as you can imagine. It was a small thing. And we were brought in to solve the case. We had to go in there and get evidence. And what had happened, the long story short, is that as normal, they put the order in for the actual dried feed, which was extruded, but it was a rush order. And when they delivered it, we questioned, saying, "Well, what did it look like?" Said it was warm, it was moist. And the problem with that is that they trusted their supplier. They were pals with them. Why would they do this? But in this haste, they put it into the silo, which was basically an incubator. And the worst thing happened. Listeria monocytogenes took hold. And to those who don't know about Listeria monocytogenes, which I assume most people do, this is what causes death of goats, and this is what causes stillbirth. And the lesson learned really on this case was that even though we like to trust people, the reality is in the modern food production facility, you can't trust anyone. And all they had to do was go, and I know I'm not testing earlier on, but that's a simple test, isn't it? If it's warm, dry, and it's obviously not been dried sufficiently, we assume it's been processed sufficiently, then that's an issue, and ensuring that everything's sanitary. So even if you know the person, don't always check the loads before you go in, because it can be devastating, which it was. So that was one example. Another example we had with a feed producer was they produced basically gluten-based feed, and they kind of departed from this sort of venture to make gluten fertilizer, because gluten fertilizer doesn't have all these nasty chemicals. But the problem is that they just followed the instructions and they never questioned. And long story short, they changed the formula. Basically, the person who hired this or commissioned this facility, they basically changed the formulation, and the company just produced it. And obviously it went very wrong. It spoiled very quickly, exploding bottles. And they were trying to get litigation, say, "Well, you told us to do it." And they say, "Well, you should have not done it," anything like that. So you've got to be wary. Anytime you enter a contract, be sure what you're doing. And the last example, because like I say, I don't want to go too many, was an interesting one at a pet food facility where they did pelleted feed. And they were getting these salmonella positives, and they couldn't trace it anywhere. They went through all this root cause analysis where they said, "Oh, it's this ingredient, that facility." But what was happening, to long story short, is that when they found a salmonella positive, they went in with their hoses of water and tried to sanitize the area rather than doing a root cause analysis. So they were basically sanitizing an area where all the evidence was. And after we did our investigation, we actually found the culprit, which was just a small, tiny crack in a pump casing, where basically the water was getting in, the salmonella was just growing into biofilms and contaminating all the products. So there's lessons we learn as, like I say, academics. We can go in there and look objectively on things like that. And anytime you have issues, it's all through root cause analysis and having controls in place where you don't set yourself up for failure and things like that.
I really like those stories, and I like that kind of that focus on that root cause, because that kind of goes through all three of your stories there. Of that last one's particularly interesting of you thought by solving the problem, what you do is just go clean everything. But what that did was not allow you to then go find your problem, because then you cleaned away the problem for just long enough that you couldn't find it. And then it came back up. And on the one with the goat feed, I think I agree with you from the standpoint of if you're going to trust a supplier, you better know a lot about what kind of quality methods they're doing and all that sort of thing, to make sure that they're someone that you're going to consistently get things from. So not only saying, hey, the feed is good, but also what do I know about their practices? And so if you're buying feed from a large facility in bulk, that sort of thing, actually knowing what are the kind of things that they do in their facility that will keep my feed safe. And if I'm buying something in a bag, I want to do some research on who is this company, and are there any third-party program seals that are on their bags of feed that let me know that, oh, they must subscribe to a particular program that I'm sure is giving them good quality. I think it also goes to show that idea of there are places from the second the ingredients show up, and in fact, wherever the ingredients come from, all the way until the animals consume it. And we focus a lot on the process itself in the facility, but from the time that ingredient is sourced to the time that animal eats it, there's a lot of places where things can go wrong, whether that be in our facility or not. So I think that's pretty interesting.
It's time for our famous 3.
All right. So in finishing up, there's a few questions we always ask our guests to try to give some information to our audience. The first is, in your particular area, and of course, in this case, it would probably want to be something that is not incredibly scientific in nature. I'm not going to send everybody to go read a textbook, but is there a particular resource, and it could be a book, or it could be a periodical or a website or something, that you would suggest, hey, if you're in the animal food industry and you're interested in learning more about microbiological safety and things like that, this would be a good resource for you to familiarize yourself with?
It's quite timely, actually. We've just finished our FAO, the FAO of the United Nations Food Safety Toolkit. And what this toolkit is, and you can go online to find it, we call it the Food Safety Toolkit for some odd reason. And what that does, it serves animal feed producers, farmers, anybody to go in. And what the FAO have is a wealth of knowledge about everything you could think of. So I would promote that one for sure. Make sure obviously the material is genuine, because it's very easy to get misinformation. That's what I like about the FAO. So the FAO, it's called the Food Safety Toolbox, but animal feed people will certainly benefit from it as well.
For sure. Absolutely. That's a great suggestion. How about a resource outside of the area of expertise? Things that, whether it had to do with management or dealing with people or anything like that you found particularly valuable in your career, again, a book or something that you said, hey, you know what, I think everybody should read this kind of a thing.
It's an interesting one. Like, the closest I've ever come to appreciating, and I don't really appreciate it, to be honest, is the Food Safety Culture by Frank Yanis. And some people say, well, it's a very woolly concept. It's basically, at the end of the day, food industry, whether it's a feed industry, whether it's a food service outlet, whether it's a farmer, it's doing the right thing. And it's quite interesting. Certain people don't do the right thing. They do the opposite of right. They'll do it. And what I like about Frank Yanis' book, called basically Food Safety Culture, is the fact that it introduces this concept, who tries to understand why people do the things they do and how to improve it. And the other sort of book I found, I call it inspiring more than anything else, was Poisoned, which really tracks the story. And there's a Netflix, I think, on this. Poisoned is the story about the E. coli 0157 outbreak, basically back in the 93, which I think was a big game changer. What it does is take the sort of lawyer involved, Bill Marler, and how he strove to change the system, which eventually does and still does to this day. So if you want inspiration, you can watch that or you can read that. But I think that's what it's to do with, is getting people to do the right thing. And it might sound easy, but in reality, it's very difficult. But That's what it is.
Absolutely. And that kind of leads into our last question of, if you could identify, and it could be in academia, it could be in the people you work with in the industry, but if you could identify this is a specific trait that I see in the people that I've worked with that really makes them successful, what would you describe that might be?
I would say it's literally 100% dedication. I remember in my youth, I went to a judo class. I never got past white belt. But the instructor said something really powerful, which I remember today. And they said, if you're going to do anything, always put 100% in. Don't go by halves. And I think I've lived by that kind of virtue. So, when we go to do research, we go 100% in. It might mean working 7 days a week. It might doing things like this. But I can see the point. And when I see people fail, it's because they don't do it. It's kind of half-hearted. So I always go by that motto, even though it didn't teach me judo. I suppose it gave me a good kick in life.
There you go. Absolutely. Well, once again, my guest today has been Dr. Keith Warriner, Professor of Food Microbiology at the University of Guelph. Thank you very much, Dr. Warriner, for joining us today.
Well, thank you for having me.
Again, I'm Adam Varenholz at North Carolina State University, and this has been the Feed Science Podcast.